before we get started, are there any questions over the homework assignments? Any of the problems you want to see worked or done or had questions on? I believe this is where we finished yesterday. We did the first problem, but did not get started on the second one. Solving the system of linear equations in 3 variables. Now, the first thing we want to do is pick a variable to eliminate out of the other 2, and then pick a eliminator equation. We can remove it from the other 2. Now, as we look at this here, x, y, and z, we need to determine which one we want to eliminate or remove from the other 2 equations. Now, the nice thing with this here is that x, y, and z, all of them are good choices. There's not one that's going to be, there's one that's kind of a little bit nicer than the others, but really, x, y, and z are all possible choices that we could have. Because if we picked x, we would look at the 1x. Can we multiply that x by something to get 5x? We multiply it by 5. We can also multiply it by 4 to get our 4x. So we can turn that 1x into 5x and 4x, add or subtract to get rid of it. If we looked at the y's, I can multiply the 1y by 5 to get 5y. Also, that 1y is already the same as our 1y here. So we'd only have to change it for one of the 2 equations. Or, if we did z, we can multiply it by 5 to get 5z. We can multiply it by 3 to get 3z. We're not so much worried about the sign. We're just wanting to get the numbers to be the same. X, y, or z, which one do we want to eliminate first? X. We can go with x. And since we're doing x, we want to pick the eliminator equation, the one that we are able to turn into the other 2 x's, so we want the 1x. Now, the non-eliminator equation, we're going to write underneath. 5x plus 5y plus 5z is equal to 3. (4x plus y minus 3z equals -6. Now, it doesn't matter which equation we eliminate the x out of first, because we're going to most likely end up doing it for both. Now, if we start with the one on the left, what do we need to multiply x by to get it to be 5x? We need to multiply by 5. So we come over here, we're going to multiply the entire equation by 5. 5 times x is going to give us 5x. 5 times y is going to give us plus 5y. And 5 times z is going to be plus 5z. Is equal to 2 times 5 is 10. And once we finish multiplying through, we're going to put it under the equation we want to eliminate x from. We'd have 5x plus 5y plus 5z is equal to 10. Questions on any of this so far? At this point here, we need to either add or subtract to get the x's to cancel out, to go away. If we added 5x plus 5x, 5 plus 5 would give us 10. So we can't add. We're not going to add. We're going to need to probably subtract. 5 minus 5 is 0. Yeah, you can put it on my desk. Because 5x minus 5x would indeed give us 0. That's what we're wanting. Which means we're going to have to subtract the 2 equations from each other. We can move on to y next. 5y minus 5y is 0. Okay. 5z minus 5z is 0. So it turned out that the entire left side of that equation became 0. That's fine. On the right side, we have 3 minus 10 is negative 7. And that tells us that we have 0 is equal to negative 7. Is that true? No, 0 does not equal negative 7. Those are not like numbers. That is a false statement. Yes? If we ever get a false statement, no solution. What that's telling us is that those two equations, those two original equations, are parallel to each other. So equation 1 and equation 2 are parallel to each other. They will never cross. They will never intersect, which means we will not have a point or line that all three will share. So as soon as we get a false statement, it's no solution. We're done. We don't even have to worry about the rest of it or the other equation. It's no solution. Questions on this here? We're ready for the next one. X minus y plus z equals negative 3. X minus y minus z equals negative 3. 5x minus 5y plus z equals negative 15. Again, when we start this, we need to pick a variable to eliminate first and an equation to eliminate it. Because really we're looking for what value of x, y, z is going to make this true. And because all three values, or all values of x and all three equations y and z are going to be the same, or we're looking for it to be the same, we can add or subtract to get there. Which one do we want to try or want to eliminate first? Because it really doesn't matter which one we choose. Because if we look at this here, if I looked at x, these x's are already the same, so we don't have to do anything to make either one of them be the other. And the last one, 5x, I can multiply x by 5 to get 5x. So x is a nice choice here. Y and y are already the same. And if I want to get either one of them to be 5y, we multiply by 5. Z. What's the number in front of all the z's? 1. They're already the same, yes? So if we wanted to, we can just start with z. We're saying we're eliminating z first because I don't have to do anything to the eliminator equation, the one that's going to remove it from the other two, to get them to be the same. So that's kind of nice. I don't have to multiply. I don't have to manipulate it to get them to be the same. So we can pick z, but we still need to pick an eliminator equation, one we're going to use to remove z from the other two. And since it's all the same z, we just need to pick an equation. 1, 2, or 3. 3. This is our eliminator equation. So the other two, we're going to go on and just list out. X minus y plus z is equal to negative 3. And x minus y minus z is equal to negative 3. Since the eliminator equation, the value in front of z is the same, we don't have to multiply, we can just plug it in. We can put it underneath it. Now we need to figure out if we're going to add the two equations together or subtract them. Z plus z, if we added them, what is z plus z? 2z. We need it not to be 2z, we need it to be 0. Z minus z. That would be 0, yes? So it's saying we have to subtract. If the signs are the same, we subtract. If the signs are opposite, we add. Now we can go through and figure out what our equation is. So our first one we have is x minus 5x, 1 minus 5, is negative 4, and we do still have our x. Then we can move on to y. We have negative y minus negative 5y. Our negative and negative 5 minus and negative 5 are going to make a plus. So we have negative y plus 5y. 5y minus y would give us positive 4y. Negative 1 minus negative 5, positive 4. Z minus z, as we said, 1 minus 1 is still 0. It cancels out just like we wanted. Equals negative 3 minus negative 15. Negative and negative would make a positive. So we have negative 3 plus 15. 15 minus 3 is 12. Positive 12. Questions on anything we've done so far? Now we need to do the exact same thing to the other equation. 5x plus 5y plus z is equal to negative 15. For this one here, would we add the two together, add the two equations together, or subtract them? Well, the last one we subtracted, yes? So negative z minus z, negative 1 minus 1 would be? 1 minus 1 is negative 2. Negative 1 plus 1 is 0. So just because we subtract on one of the equations doesn't mean we're going to have to do it on all of them. That's why we're checking it each time. Because our negative z plus z, the signs are opposite, so we add. If the signs are the same, we subtract. Z signs are opposite. One's positive, one's negative, so we're going to add them together. Negative 1 plus 1 is 0. X plus 5x is 6x. Negative y plus 5y is going to be plus 4y. Z plus negative z. 0. Negative 3 plus negative 15. Yep. Is negative 18. There's a mistake there. I know something was off. What's up? What's wrong? Yes. Because what does the original equation say? 5x minus 5y. Now it feels like it is going to make a difference because we have minus 5y, yes? So if we look at this here, we actually have negative y plus negative 5y, which would mean that this is not positive 4y, because a negative 1 plus negative 5, negative 1 minus 5, so it'd be negative 6y. That's the only difference. Yes? Mm-hmm. Yeah, so this changed to a plus because our negative negative. That's also one of the reasons I like putting the minus all the way through, so if we have that double negative, we can change it as we go through. Good question. Any other questions on this here? So we got rid of z, so we have two equations with two variables now, yes? we need to eliminate another one. We need to either eliminate x or y. So if we did x, we need to see what we need to multiply 4x by to get 6x. Well, there's not a nice number for that. Or we can multiply 4y by something to get 6y. Again, there's not really a nice number for that either. In this case, because this we're kind of stuck to picking one, we're going to have to multiply both equations by something to get them to be the same. And one of the nicer ways to do this is if we say we're going to eliminate x out of both. I take the other number and multiply it. Because one way we can do it is least common denominator, least common multiple. What is the first number that 4 and 6 will both be going up? And really that would be 12. 4 times 3 is 12. 6 times 2 is 12. Or what we can do is I take this equation and multiply it by 6. Now it seems arbitrary that I pick 6, but I pick 6 because 6 is the number in front of the other x. And if we multiply this through here, 6 times negative 4 is going to be negative 24x. 6 times positive 4y is going to be plus 24y. And 12 times 6 is going to be 72. What do you think we're going to multiply our 6x minus 6y by? 4, because that's the number in front of the x. Now, we're not too concerned about the positive or negative because we take that into account when we add or subtract the two equations from each other. 4 times 6x is going to be 24x. 4 times negative 6y is going to be negative 24y. And 18 times 4 is 72. I will scroll back up. I think we're noticing something about these two, yes? Negative 18, thank you. I am having an off day at this point. But thank you, no. Anytime that happens, let me know. Questions about these two equations? They look very similar, don't they? So let's see what happens when we eliminate x. So we can take this one, and it doesn't matter which one we put on top. And which one we put on bottom. But we do need to put one of them on top and one of them on bottom. And we get this set up here. Now we need to figure out if we're adding or subtracting. So we're wanting to eliminate x, so negative 24 minus 24. Negative 24 minus 24 is negative 48. Negative 24 plus 24, the signs are opposite, we will add. Now negative 24 plus 24 is 0, that's what we wanted. 24y plus negative 24y. 24 minus 24 is 0 also, yes? Now, the problem we had before this also got that 0, yes? And that was no solution. However, before we say that, let's see what the other side is. 72 plus negative 72, that is also 0. Is 0 equal to 0? That's a true statement. If we get all the way to the end and we get the true statement, or one of the other two is, it is infinitely many. Infinitely many solutions. That's it. If at the start, we do our elimination, and instead of like on the last one where we got 0 equals -7, we got 0 equals 0, we need to check the other equation. Because if, I will come back to this here. What is this? It didn't. If we do get 0 equals 0 here, we still need to check the other equation. We need to do elimination on the other equation, and as long as we get, because we eliminated x, 3y minus z equals 7, we can say it's infinitely many. Realistically, it's infinitely many along that line, that equation of the line. However, if we do elimination on the other side and get 0 equals 4, that's a false statement. It's still no solution. Essentially, we need to make sure that the other one's not false. It could be that those two cross infinitely or are the same plane, and the other one's parallel to it. We just need to check and make sure. Questions on this here? Now, there is a set equation for this here. Especially in pre-cal, we go through the actual process of finding this solution set. So for any value of y that we plug in, it would give us a solution for this here. So if we said y was, say, 2, 2 minus 3, comma 2, comma 0. Well, 2 minus 3 is -1. So -1, 2, 0 would be a solution. Any value that we can plug in for y would make a solution. So we could say y is 3. Well, 3 minus 3 is 0, so we have 0, 3, 0. Would be a solution. We could say y is -4. -4 minus 3 would be -7, so -7, -4, 0 would also be a solution. That's why it's infinitely many, because we have infinite values that we can plug in for y. So every point that satisfies this equation, this setup would work. We don't say all real numbers because there are a lot of numbers outside of these here too. Because if we have any value for z that's not 0, would not be included. We're going to look at least one more. Do some more of these here. We will come back to these again. X, Y, or Z, which one do we want to eliminate first? There is one that's kind of nice across all of them, yes? Why? Because we have 2y, 2y, and 2y, yes? Anytime I don't have to multiply by something, that's the one I'm always going to pick. Less work is always better. Yes, sir. Yeah. We can pick it for the eliminator and use it. So we have opposite signs. I think that's what you're asking, yes? It wouldn't. It just changes. So the big difference between the negative and positive is going to be if we add or subtract. Some books would say that we need to multiply the -2y by -1 so that the signs are the same and we always subtract, so we keep the operation the same. I think it's easier. Let's just focus on getting the number and then see if we add or subtract. Now we could pick the top equation as our eliminator equation. Now on the left-hand side, Z's or Y's are already lined up. So we can just fill in our x minus 2y plus z equals -11. Now this does give us something interesting, and we'll see what it is here in a minute. So we picked y to eliminate first. So we have 2y and -2y. Would we add or subtract? Subtract 2y minus -2y. So 2 minus -2 would be 4. 2 plus negative 2 would be 0. If the signs are opposite, we add. If the signs are the same, we subtract. So 2y plus negative 2y, 2 plus negative 2 would be 0. That's what we wanted. Let's look at the other terms. 3x plus x. 3 plus 1 is 4. So 4x. I see some questioning looks because we're looking at z, yes? Negative z plus z is 0, yes? That's fine. We can have that simplify out. Equals 7 plus negative 11. 7 minus 11 is, all right, negative 4. So we had 2 simplify out, yes? That's not a bad thing. That's actually nice. Because again, the reason we're doing the whole elimination is to get down to one equation with one variable, because we can only solve for one variable at a time. The left side, I did that elimination and we got rid of 2. Can we solve for x? Yeah, there's nothing saying that we can't immediately just say, here 4x is equal to negative 4. We're going to solve for x. It's going to make things nicer. We divide both sides by 4. Telling us x is equal to negative 1. That also means we have one less step we have to do in solving. Because the other equations, we're still removing y from the 2. Because when we remove y from the other equation, we should be left with an equation that has x and z. We already know what x is, so then we can use it to solve for z. Questions on any of this so far? Looking at the other setup, 2y and negative 2y, would we add or subtract? 2y minus negative 2y? 2 minus negative 2 is 4. 2 plus negative 2 is 0. So again, we're going to need to add. If the signs are the same, we subtract. If the signs are opposite, we add. X plus negative x is 0, yes? 2y plus negative 2y. That's also 0, yes? 4z plus z is 5z. Negative 9 plus negative 11. 9 plus 11 is 20. Since we added 2 negatives, it would still be negative. So negative 9 plus negative 11 is going to be negative 20. This is nice. So to solve for z, we would divide both sides by 5. Almost. Negative 4. The degree of the number, just negative divided by a positive would still be negative. So we found x, we found z. Yes? Yeah.
So whenever we figure out like x, are we able to put that x?
Yeah. Yeah, we can, at this point, we could have put it in the other two and solve from there. Now, part of the reason I didn't put it in there is I was hoping for one of two things. I was hoping that when we eliminate y, we would get an equation with x and z. I can plug it in there and solve. Because we could put it in, but we do need to solve And when I say solve, instead of leaving it as, say, so negative negative 1 plus 2y plus 4z, you don't need to write here. I would need to move this to the other side first. So we'd have our positive 1 minus 1. So we would really be looking at positive 1 subtracted here. And we'd have to do it for both equations and then go from there. But it worked out nicer in the fact that we now have both. It just got z by itself, so I solved. Kind of makes sense? Now the last thing we need to do is find the value of y. We can pick one of the three original equations, plug it in, and solve. I'm going to pick the third one and plug it in. So we'd have negative 1 plus 2y plus 4 times negative 4 equals negative 9. Now we just need to find the value of y. All right, let's wake up. Negative negative 1 is 1. 4 times negative 4 would be negative 16. Our like terms of 1 and negative 16, we're going to combine them first, which shows us we have 2y minus 15 is equal to negative 9. Then we would need to add 15 to both sides, because negative 15 plus 15 would be 0. Telling us 2y is equal to 6. Last but not least, we would divide both sides by 2, telling us y is equal to 3. So the solution would be the point negative 1, 3, negative 4. Questions on how we did this here? Now the nice thing is kind of you're seeing here, the process in which we do this, the numbers change, but the process doesn't. We do the same type process over and over again. Now we do get some quirky features like this one here, because we solved for, we removed y out of the first one, it gave us 4x equals 4, negative 4, we solved for x, we got that there. Funny enough, first hour, we did this same problem, and we did not actually get z by itself. We actually got it in terms of x and z. Plug z in, solved. Here it just gave us z. So it's going to be a little different, but the process doesn't change. As soon as we get an equation down to one variable, we solve for it, and we're going to utilize it in the rest of the problem to solve for the other values. Questions on this here? Questions on anything we've done so far? Let's look, I'm going to look at one more. We'll look at one more together, and then we will be done with this here. If you notice, I believe that there are 2 more left. Yes? I will let you pick between those 2 which one we do. Looking at the second one? Or the third one? Is there a third? Oh, number 3? Yep. Let's look at number 3. X plus y plus z equals 8. X minus y plus z equals 8. And 2x plus 2y plus 2, or 2x plus y plus 2z equals 16. X, y, or z, which one do we want to eliminate first? Y, because we have 1y, 1y, 1y. 1y negative 1y, 1y. All the values are the same. It seems like that's going to be a nice one to go with first. Which one do we want to use as our eliminator equation? Top, middle, bottom. Middle. Since the numbers in front of y are already the same, we don't have to multiply it by anything. We can just list it underneath. And since we're wanting the y's to eliminate, we need to figure out if we're going to add or subtract. Because we have y and negative y, so 1 and negative 1. 1 minus negative 1 would be 2. 1 plus negative 1 would be 0. Since the signs are opposite, we're going to add. X plus x is 2x. 1 plus 1 is going to give us 2. 1, or y plus negative y, 1 plus negative 1 would indeed be 0. Z plus z, 1 plus 1 would give us 2z. And lastly, 8 plus 8 is 16. Y's are already the same in the other equation also. We have 1y and negative y. We have positive 1y and negative 1y. What do we add or subtract?
All the students in the office: Jeff Marino, Ivan Willis, Dayton Jackson, Em Irwin, Dale Jackson, Colton Martin, Cole Pendleton, Bodie Hood, Langston Sixkiller, Jacob Martinez.
So again, we're adding because 1 plus negative 1 would be 0. We're going to have to do some multiplying. 2x plus x is 3x. 2z plus z is going to be plus 3z. 16 plus 8 is 24. This has the making for, at least it seems like, there's a good chance this might be infinitely many. Because we have the same x's, same y's in each equation. Now to get there, we're going to have to multiply both equations by something to get either x or z to be the same. Do we want to eliminate x or z? We can just pick x. For the equation on the left, to get the x's to be the same, we're going to multiply by 3. 3 times 2x is going to be 6x. 3 times 2z is going to be plus 6z. And 16 times 3 is going to be 48. On the right, we're going to have to multiply everything by 2. 2 times 3x is going to be 6x. 2 times 3z is going to be plus 6z. And 24 times 2 is going to be 48. So, questions on how we got here? Now we would add or subtract the two equations. We can see they are the same equation, yes? So when we do subtract, we're going to get 0 equals 0, telling us that there are infinitely many solutions. Questions on this here? Five problems. 3 through 5, 11, and 13. I will tell you this, one problem is no solution, one problem is infinitely many. 3 of them will have a single point as a solution. One of them is going to be no solution, one of them is going to be infinitely many. Again, this is one of those I'm not giving you a ton. I'm only giving you 5 because, again, it does take a little bit of time to do these. So we're not doing as many of them.